Okay, guys, what's up? Mr. Winslow again, coming to you live from the arcade, and hopefully, yeah, your lessons are going okay. But I'm going to teach you another law of signs lesson here, law of signs, and the scenario I'm going to teach you today is called a side-side angle, or the um, big US case. Okay. So the reason they call it the ambiguous case is because when you get a side-side angle, you don't necessarily know which way it's going to end up. That's why they call it ambiguous. Okay. Hopefully I spelled ambiguous right. But the reason it's ambiguous is, you'll see in a second, there's actually a couple different ways you could build it based on the scenario. But the way I remember this is, you see this, if you put a mirror up to this and spell it backwards, you'd have a bad word. This is going to be the worst scenario you could get, because you kind of have to make some decisions. Okay, so I'm going to give you a couple examples here. And just a friendly reminder, law of sines, remember, it's the easiest thing to remember. You say sine of angle A over A equals sine of B over B equals sine of C over C. And it's just a relationship between the sine of whatever angle and its corresponding side, right? So saying that, we're going to look at a couple scenarios and show you how this works. Okay, so I've got a couple examples. I'm going to be using triangle ABC because I'm boring. But here's the first example. Okay, so let's say I say in triangle ABC, I'm going to say angle A is 113 degrees, side A is 25, and side C is 14. Remember, the capital letters are the angles, the lowercase letters are the sides, right? So I'm going to draw my boring triangle here. Not drawing the scale, don't care. ABC, right? This is 113. This is 25. I know that's right across, right? And C, right across from C, would be 14. Now, take a careful look at this, okay? Essentially, what's happening here is this. We need to complete this triangle, right? In triangle ABC, this is the case, okay? We'll just say complete the triangle. Okay, complete the triangle. So what we need is, we need angle B, angle C, and we need side B here, right? Okay, now, first off, the question is, you could probably assume yes, but the question is, can you use the law of sines here? Okay, well, you can, because you have angle A and side A, right? Anytime you have a matching pair like that, law of sines is good, okay? So the way I'm going to set this up is, I'm going to say, okay, the sine of 113 over 25 equals, okay? Now, you may have noticed this, but I actually have to solve for this because I've got its corresponding side, right? I have nothing with B. So B's out of the question right now, right? But I can solve for this angle, and that's actually the only thing I can solve for right now. So what I'm going to say is sine of 113 over 25 equals the sine of C over 14, okay? Now, this is different. This is different than what you did yesterday, because yesterday you were always solving for a side, okay? Here you're actually solving for an angle, okay? So what I'm going to do is the same thing I did yesterday, is I'm going to take this times this times this, cross multiply, do a little algebra, right? So basically, here's what you got. 14, right? 14 sine 113 equals 25 sine C, and all you got to do is divide both sides by 25, right? So you have sine C equals 14 sine 113 over 25, okay? Okay, now, here's the deal. Okay, what I'm going to do is, I'm going to go to my calculator real quick. I'm going to type in 14 sine 113 divided by 25. And it says, you see that? It says like 0.515-ish, okay? 0.515. So I'll say that's about 0.515, okay? So there you go. Sine C is about 0.515. Now, that's not C. That's the sine of C. So as you recall, what I have to do is I have to put inverse sine 0.515 approximately, right? Inverse sine 0.515. Remember that 0.515 is a ratio, right? So inverse sine 0.515, or you know what? I'll do inverse sine of the answer just to get a more accurate one. I'm getting like 31.03. So 31.03. Okay. So you're saying, okay, Mr. Windsor, you big dummy. That's not hard at all. So what? You had to hit inverse sine. Okay, well, that's partially true. But make sure you have all this down, okay? But here's what I need to talk to you about, okay? And this is why I'm such a great teacher. I taught you this last semester, and this is something you can apply. You say, okay, great. 31.03, and I'm just going to go around and find the other stuff. I'm done. I'm done listening to this lesson. This is stupid. Well, here's the deal, okay? You remember inverse sine? How it was, you have to limit it to like the right half of the circle, right? So it's either in the first or fourth quadrant. So when I go to the calculator, it's got to give me an answer over here, okay? But did you know that if 31.03 has a specific sign, right? 31.03 has a specific sign. There's another angle over here that has that exact same sign, okay? And the calculator didn't give you that one because it has to give you stuff over here, right? Well, the way you can find that is basically, this is 31.03. This is also going to be a 31.03 from 180, right? So you could just take 180 minus 31.03, and you would get 148.97, okay? You get 148.97. So here's the point of that, okay? Let me write that a little better. Sorry. 148.97, okay? Here's my point, okay? You can check me on that, but 3103 and 148.97, if you type in the calculator, they're going to have the exact same sign because they line up as the same Y's, right? Okay, so my point is this, 148, I'm going to jot that down, 148.97, okay? My point is this. There might be another triangle A, B, C, with 113 here, 14, and 25, right? Well, let's just say in a parallel universe, I try to put 148.97 here because that would match the law of sines, right? Because these two have the same sign, okay? Here's what you need to look at though, okay? See 113 and 148.97? 113, 148.97. If you add those two up, guess what? You're already over 180 and you have no room here, okay? So therefore, that would not work, okay? Here's the big deal with the ambiguous case, okay? Here's what you need to tell yourself. Anytime you hit second sign, okay, remember how we hit second sign right here? Anytime you hit that, you not only have to take this one into account, but this one, okay? And if this one can fit in here and still be under 180 and have room for a third angle, you would actually have two separate triangles, okay? So this is what you call an ambiguous case with one answer, okay? This has one answer because that other angle would not fit, okay? So now I can breathe easy. I can come back over here and I can find the two missing things, okay? The two missing things are angle B and side B, okay? So saying that, here's what we're gonna do. Okay, I'm gonna erase all this because it doesn't matter, okay? So what I'm going to do is I'm going to find this angle B first, right? So if I take 113, right, and I take 31.03, and I subtract that from 180, I get 35.97, okay? Got it. Now I just need B. So what you're going to do is you're going to go back to yesterday and use the law of sines, okay? So watch this. Sine of 113 for 25 equals the sine of that's 35.97 over B. And so we just do a little cross multiplication, 25 times this times this. So I don't know if you figured this out yet, but basically if you multiply those two together and then if you multiply those two together and then just divide it by that one, you'll have it. So if I type in, check it out, 25 sine 35.97 over sine 113, I will have B. Okay, that's a 113 there. Okay, so, and by the way, I know that B has to be bigger than 14 because this one is a bigger angle than this one, right? So I bet you anything it's between 14 and 25. So if I type in 25 sine 35.97 divided by sine 113, I get, just as I suspected, 15.95. And I just did an ambiguous case. And this ambiguous case had how many answers? It had one answer. It had one triangle that could be formed, okay? Now, the reason it's ambiguous, this is kind of interesting. I'll go off on a tangent here, okay? So there are your answers right there, right? Okay. This is a one triangle scenario. I'll show you the other two scenarios here in a minute. But the reason this is ambiguous is this. If you look at what they gave you, so let's just say I had this A, B, C. They said this is 113, right? They said this is 25, and they said this is 14, okay? The reason this can be ambiguous is, like, they didn't give you these two angles, right? So I could kind of, as long as this was 25 and this is 14, I could kind of hinge that how I wanted to. You see what I'm saying? That's why there are different scenarios that could pop up with this. But I'm going to tell you right now, you could have 0 triangles, 1 triangles, or 2 triangles with a side-side angle, okay? That was a 1 that we just did, okay? That was a 1 triangle scenario, okay? The next one I'm going to show you, I'm not going to tell you, I'm going to let it be a surprise, but the next one will be different, okay? So check it out. Here's the next one, okay? So I'm still doing triangle ABC, okay? I still want to complete it. So here are the things I'm going to give you, okay? I'm going to give you angle A is 20, C is 34, and A is 32. So I want everybody to do right now is I want you to pause this video and I want you to draw a scenario. This is triangle ABC. I'd like you to draw this, okay? So what it's going to look like. You got angle A is 20, A is 32, and C is 34. There it is, okay? Now yours might look a little different, but I mean, it's just got to be A and C, okay? Now, once again, I know I can use the law of sines because I have angle A inside A, right? So here's what I'm going to set it up, okay? Now, what do you think I have to solve for first here, okay? You have to solve for C because you have nothing with B. It's kind of like the same thing as it did, but you have nothing with B. So here's what you do. You say sine of 20 over 32 equals sine of angle C over 34. And you do your cross multiplication. So 34, right? 34 sine 20 equals 32 sine C divided by 32, right? So 34 sine 20 over 32 equals sine of angle C, okay? So I'm going to get a little decimal approximation here. 34 sine 20. Let's see, 34 sine 20 divided by 32. And I put an extra parentheses there because I'm an idiot. 34 sine 20, excuse me, divided by 32. 0.36-ish, okay? So sine of angle C is about 0.36, okay? And here's the big kicker, okay? I'm having to hit inverse sine, okay, of 0.36. Now, my calculator, I'm telling you right now, it'll give me an acute angle, okay? Guaranteed. So watch this, inverse sine of all that crap, and I'll get 21.31, let's say. Okay, 21.31. Okay, so what I can do is I can come here and say, okay, I got 21.31, okay? And you say, great, let's just go for it. Well, here's the not so fast, okay? 21.31 is right here. There's another one over here, supplemental to that. They're always going to be supplemental when you do this, okay? There's another one over here that has the same sign as 2131, okay? So if you want to know what that one is, you take 180 minus that, and I'm getting 158.69, okay? Now hear me out. Here's why we're doing this. 21.31 and 158.69 have the same sign. If you don't believe me, pause it and check it out, okay? But here's what I have to do, okay? I have to come over here, and I have to draw another triangle. A, B, C. A is 20, given. This is 34, this is 32, that's all given, right? Same stuff. But what I'm going to do is I'm going to put a 158.69 here and just do a little experiment, okay? 158.69. Now, 2131, 158.69, they both have the same sign, therefore it would match up still with the law of signs, okay? However, this is unique, watch this. 158.69 plus 20, okay? That's 178.69. That's just barely under 180. So guess what? This would actually work as well as this, okay? Now these are not drawn to scale, but this is what we call a two triangle scenario. So if you get a two triangle scenario and they say, what's angle C? Well, you say it's 21.31 or it's 158.69. You have to give two separate answers, okay? Now, we got to complete both these, right? Now, I suggest you do it one at a time, but I'll show you how you can kind of look at this, okay? Let's say you look at angle B, okay? Over here, angle B, it's very simple. You take 180 minus 20 minus 21.31, right? And you get 138.69, okay? 138.69, okay? If you came over here, 20 plus 158.69, right? And you subtract that from 180, it's a very small angle, but it is going to be something, right? It is 1.31 degrees, okay? So when you say, hey, what's angle B? Well, it could be 138.69 or it could be 1.31, okay? It's actually both. Because once again, this is a two triangle scenario, right? Now, what's left to find? Okay, we just got to find angle B, or excuse me, side B. So what we do, let's say I did this one first, okay? So I just have to do the law of sine. So I'm going to say something like this. Sine of 20, right, over 32 equals sine of 138.69 over B. Okay, and with a little cross multiplication, here's what we do. We say, check it out, write that down. Okay, we say 32 times this divided by that, and we would have angle B, or side B, right? So 32 sine 138.69, right, divided by sine 20. This is yesterday's stuff. Hit enter, and I'm getting 61.76. Okay, so 61.76. Okay, and that is one answer for side B. Okay, this one's going to be different. I can guarantee you this one's going to be smaller, right? But here's what we do. Okay, we come over here, and did you know that that same ratio is going to work? Look, it's still sine of 20 over 32 equals, let's say I did this, sine of 1.31 over B. And someone might say, well, I want to use this one and this one. Great, it'll work. Okay, you can use whatever you want. I'm just kind of lazy, so I use what they gave me. I use the 20 and the 32. You see what I'm saying? And you can use that every time. But with a little algebra here, look, sine of 1.31 times 32, then you divide it by this. Check it out. Sine 1.31 times 32, hit enter, divide that by the sine of 20. And over here, I got about 2.14, okay? Here's what I can promise you. I can promise you that this triangle and this triangle, the law of sines would hold true for both of them, okay? Do you notice how this angle B was not fixed, okay? So this one they swung it out. This one, if I drew it to scale, would be swung in. This side is much longer when it gets swung out. This side is much shorter when it gets swung in, okay? But they are both scenarios that would hold true for this stuff right here, okay? This is what you call a two triangle scenario. This will be the most work you do on a law of sines problem, okay? Because when I say what's angle C, well, you have to give me two separate angles, okay? What's the relationship between this angle and this angle? They are supplementary, okay? They add up to 180. Do these two add up to 180? Not necessarily, okay? These actually don't, right? So here you have it, okay? This is a law of sines, ambiguous case, two triangle scenario, right? You know you can spot these when you have something called a side angle, okay? Go back to originally what we had. Watch this. Originally what you had here was you had two sides with an angle that wasn't in between them, right? That's what you call a side angle, okay? In a side angle, you're always going to have to hit inverse sine, okay? Anytime you have to hit inverse sine on a law of sines, you know it's bad news, okay? So this particular problem, every answer you give, you would have to have given two separate answers, okay? Someone said, Mr. Wenzel, you wouldn't put one of those on a test, would you? Heck yes, I would. Because it's easy once you get the hang of it, okay? Now, last scenario, okay? We did a 2, we did a 1. This one's going to be something unique, okay? So let's see if we can figure this out. So same thing, triangle ABC, okay? We're going to have a side angle scenario, okay? So watch this. Let's say measure of angle B is 82 degrees, A is 35, and B is 13. So take a minute, if you would, pause your YouTube video and draw this out for me, okay? I'll do it here. Okay, so here we go, side angle, bad. Okay, what do we have to solve for here? We have to solve for A. The reason I know I can use the law of sines is because I got B and B, right? It matches up. So it's so easy, watch. Sine of 82 over 13 equals sine of angle A over 35. And we just do our little algebra, right? So we say 35, watch this. This is how easy this is, 35 sine 82, right? Divided by 13 would equal sine of angle A, okay? So the way you do this is you just say, okay, I'm going to do inverse sine of all this stuff. That'll give me our answer, okay? So watch this. 35 sine 82 divided by 13. So look, 35 sine 82 over 13. I got inverse sine of 2.66. Now I'm going to stop there. You know why? Because I remembered last semester, and you'll never have a sine over 1. So guess what? When you hit this, it'll say error, because your calculator is not an idiot. Well, it is an idiot. It just does what we tell it to do, right? Inverse sine 2.66, you can't have it. Okay? What's the highest sine could be? 1. That's right, kids. You can't have a sine of 266. So when you say, hey, I got a sine of 266, you're saying the hypotenuse is lower than the opposite, and that's not ever the case, okay? So error, and this is the easiest one. You say, okay, you can't have a triangle like that. So there's no triangle that can be built with this scenario. Reason being that 82 would be too big. It doesn't matter how long this side is right here, right? This 13 being 13 and that being 35, that 82 is too big of an angle to close off the triangle, right? So technically you couldn't draw the triangle, so that's what you call it 0. So long story short, here we go. This is the last type of law of sines you're going to see, okay? Go back and review the other video, make sure you understand those. But when you see side angle, and the kicker is you have to hit this on a side angle because you're looking for an angle, right? Okay, the other ones all had 2 angles in them, and they're easy. But this one only has 1 angle. You have to solve for another one using this. Anytime you hit this, you have to pause and think. What's the other angle Look, what's the other angle that has that same sign? And would it fit in that same scenario that was given to me in the example? If you get an angle, then you look at this one and it won't fit, that's a one triangle scenario. If you get an angle, you take that other one and it would fit, that's a two triangle scenario. If you hit this button and it comes back in error, that's a zero triangle scenario, okay? 0, 1, or 2. That's why they call it the ambiguous case. And that's it, okay? So, what's today? Today is 1/10/19, and I'm happy to say that baby Grayson is home and doing well, okay? He's eating good. He's all his blood works good. He had to be in the NICU for a little bit, but he's home. We're very happy, and maybe next video I can go wake him up and show him to you guys. But thanks for all the thoughts and prayers. He's doing well. He's home, and mommy and daddy are very happy. Okay, so you guys keep studying. It's looking like we're gonna have a quiz on law of sines and law of cosines next week, I think. So y'all just keep watching the videos and checking your homework, okay? And stay on top and be good to the subs. And I'll see you sooner than later, okay? You guys take it easy. Peace.